Right under our feet, there's this huge hidden world of water. And honestly, a lot of it's in big trouble. But what if the way to fight this invisible problem was with a solution that's also invisible? And what if it was all guided by an AI that, get this, actually understands physics? All right, let's get into it.
So here's how we're going to break it down. First, we'll get a real sense of just how big this water pollution problem is. Then, we'll meet our unlikely hero, these super tiny nanoparticles. We'll look at the crazy underground maze that's keeping them from doing their job. And then, this is the cool part. We'll see how a really special kind of AI is helping us crack the code and maybe, just maybe, get this whole thing out of the lab and into the real world where it can do some good. All right, so first things first, we really need to get a handle on just how massive this problem is. Because, it's a lot bigger and frankly, a lot closer to home than most of us probably think.
So look at this number, 4.5 billion. That's just a staggering number of people globally who don't have access to safely managed sanitation. And you can probably guess what that means, right? It's a huge driver of water pollution because all that untreated waste, well, it has to go somewhere. And too often, it ends up in our water.
And yeah, we've all seen the pictures of plastic in the ocean or trash in rivers. But a massive part of this problem is totally invisible. It's happening underground in what are called aquifers. This is our groundwater, and it supplies drinking water for billions of people. So when that gets contaminated, well, you've got a serious, serious problem that's incredibly hard to fix.
Okay, so the problem is huge and it's hidden. But here's where the story takes a turn. What if the solution was also invisible? Scientists have been working on this amazing tool that operates on a scale so small, it's hard to even imagine. They're called engineered nanoparticles, or ENPs for short. And you can seriously think of them like microscopic cleanup crews. The idea is you inject them into the ground and they go to work, finding and breaking down pollutants right at the source. And in the lab, oh man, in a controlled setting, they work like a charm, incredibly effective. And here's the but. This quote right here, it really gets to the core of the whole issue. It's the central problem we're trying to solve. You have this brilliant technology that's super promising in the lab, but as the researchers say, in the real world, it's just stuck. We can't get it to work out in the field where, it's actually needed. So what gives? Why is it so hard? Why can't we just take these nanoparticles that work so well in a nice, clean lab and, put them to work in the messy world right under our feet? So yeah, what is stopping us? Let's dig into the challenges, because the world underground, well, it's not a simple pipe. It's more like a super complex, totally chaotic maze. Okay, so you're up against a few major hurdles. For one, the nanoparticles themselves don't just move in a straight line. Their behavior is super complex. Then you've got the ground itself. Every single aquifer is different. It's this wild mix of sand and rock and soil, total chaos. Plus, it's crazy hard to get good data from way down there. So what happens? Our existing simulators, our computer models, they just can't handle it. They can't tell us where these little cleanup crews are going to end up. And I mean, that's everything, right? You can't plan a cleanup if you have no idea where your cleaners are going. But this is where things get really interesting. This is the breakthrough. To solve a messy, real-world physics problem, the researchers found an AI that does more than just crunch numbers. They found an AI that actually understands physics. It's called a physics-informed neural network, or PIN. And the concept here is just so cool. See, most AI, it just learns by finding patterns in tons and tons of data. A PIN does that too, but it has a cheat sheet. It's been taught the actual laws of physics, the equations for how fluids and particles move around. It's the difference between a student who just memorizes flashcards and one who actually understands the textbook. It knows the why. And this diagram really shows you how it works. On the left, you feed it some basic info, like where and when. In the middle, you see it's got two brains, two neural networks working together. One tracks the nanoparticles moving in the water, the other tracks the ones that get stuck to the sand. But the real magic, the secret sauce, is that box on the right. That's where the AI is constantly checking its own answers against the laws of physics. It's like it's asking itself, does this prediction actually make sense in the real world? Is it physically possible? That's the game changer. So that little B in BPN, it stands for Bayesian. And trust me, it's the model's superpower. Here's why. Real-world data is always messy, right? It's never perfect. A regular AI might just give you one single answer and act like it's 100% right, even if it's dead wrong.
But a Bayesian AI is smarter than that. It actually knows what it doesn't know. So instead of one answer, it gives you a range of possibilities and, crucially, tells you how confident it is about its prediction. And when you're about to make a huge financial decision based on a couple of dirt samples from deep underground, that is everything.
Okay, so the theory is awesome. Sounds great on paper. But did it actually work? Let's check out the results. Wow. Okay, the results here are pretty incredible. See that solid black line in both charts? That's the ground truth. That's the right answer from a standard simulator. Now look at all those colored lines bundled together. That's our AI, showing its range of predictions. And look, they are right on top of the black line. It's a near perfect match. The AI didn't just guess the right answer, it gave a confidence range, and the truth fell smack dab in the middle of it. That is just incredibly accurate. I mean, the researchers' own words really say it all, don't they? The B pin works. It can predict where these nanoparticles are going to go and where they'll end up. This is the piece of the puzzle that was missing. Okay, so this is huge, but let's zoom back out. What does this amazing new tool actually mean for that giant global problem we talked about at the beginning? Well, it means we can finally bridge that gap. Remember how the tech was stuck in the lab? This tool is the bridge. It connects the pristine, perfect results from the lab to the messy, complicated reality of an actual polluted site. It's like the perfect translator between a great idea and a real-world solution. And here's how it would actually work in the real world, in a simple two-step plan. Step 1. You run the model in inverse mode. Think of this like the AI putting on a detective hat. You give it a few soil samples from a polluted site, and it works backward to figure out the unique physics of that specific spot. It learns the maze. Then, step 2, you flip it into forward mode. Now that the AI is an expert on that site's maze, it can predict the future. It can tell you exactly what's going to happen when you add the nanoparticles. And that means engineers can design the perfect cleanup strategy before they even start, saving a ton of time and money. So it kind of leaves you with this one big, fascinating question, doesn't it? We usually think about AI learning from data we create, but what happens when we teach it the fundamental rules of nature itself? It seems like we might just be creating a powerful new kind of tool, one that can help us understand and maybe even begin to heal some of the damage we've done to our own planet.